Hi, my name's Dan, and this video is one in a series of videos I'm doing about vectors in Unreal. And if you've been watching the whole series, you'll be getting really bored of me telling you that it's really useful to understand vectors if you're doing stuff in Unreal. And the series is intended to give you an understanding of vectors as well as showing you how they're used in Unreal. And in this video, particularly, I'm going to look at the idea of normalized vectors. So this is not to be confused with normal vectors, which is what I did in the previous video. A normal vector is one that's perpendicular to, sticking out from a surface. Why it's called a normal vector, I don't know. That the origin of that terminology is not one that I'm aware of. I just know that that's the terminology. And a normalized vector is, the concept is kind of weirdly related, but not really, to the idea of a normal vector. So a normalized vector is if you have a vector, and a vector can be of any length, and a vector gives you length and direction. And if all you want is the direction, then the thing to do is to make that vector to be one unit in length, which is so make it a unit length vector. So if it's pointing straight up, then the vector is 0, 0, 1. If it's pointing straight off to the x direction, it's 1, 0, 0. And if it's pointing somewhere between those, it's a combination of fractions of 1, where if you did your Pythagorean maths on those three elements, it would all turn out as 1 in the end. So yeah, the length is 1. And this is useful for all sorts of things, actually. It's more useful for real things in Unreal than a normal vector is, to be honest. So I'm going to demonstrate the use of a normalized vector by doing a little thing in a blueprint. So the setup I've got here is a third-person template with a few bits of debris and junk kicking around from previous videos. And I've got a blueprint here which involves pad and a small cube. And we're going to do some stuff inside the blueprint here. What we're going to do is we're going to make this small cube a defender of this pad, so that no matter the direction the player approaches the pad from, that cube is there in the way. We can't get to the pad as a result. And we're going to do this by finding the vector from the pad to the player and then normalizing it, so we've got the direction, and then multiplying it by a fixed amount, so it's a fixed distance out from the central point all the time. And as we move around it, it will rotate around and act as a guard. Right, so let's get into it. So we want the vector from the pad to the player, so that's A to B. And when you want the vector from A to B, that's the absolute vector of B minus the absolute vector of A. So B is the player location. So we're going to do get player born, and then out of that, get actor location, and we're also going to get actor location, get actor location of pad itself, and we're going to do that minus that, give us the vector from the pad to the player. Now, as I said, we want to make that a unit length. What we don't want to happen is we don't want this block to have a relative distance to the pad, so that if the player gets closer, it also gets closer to the pad. We want to keep it at a fixed distance. So to achieve that, we're going to just get the direction of this vector by normalizing it. Normalize, which gives us a unit length vector. Now, there's a thing here called tolerance. You don't need to worry about that. That is a very small number. It seems to work just fine. That's to do with floating point numbers and dealing with the fact that sometimes you get small errors. And then we're going to multiply that. So multiplication, and as I always seem to do, just change that to a float and give this, let's make it 2 meters out, so 200 units in real. Let's move this along. So is this what we want? Actually, the vector that we want is from the pad to this this point, which is defined by this vector. So this vector gives us the vector out from the pad, so we need to add it to the pad location to get the absolute location in world space. So, pad, pull this out. And then we're going to get a small cube and set world location. And if I could spell, that would make me dangerous. So let's see if this works. Get into play, and that box is following me around. So it is doing exactly what it wanted it to do, which is it's following me. It's at a fixed distance from the central point of that pad, and I cannot get to that pad. If I jump up, it goes up with me. If I was able to go further down, it would go with me. I'm going to try and attack it from above, get up here, and do a nice running jump. No chance. Because the block blocks me. It's in the name, and this can be quite frustrating. Yeah. I've still got my free floating box from the previous video there. So that's a quick demonstration of one use of normalizing vectors is to find a direction and then multiply that up by a fixed amount. Remember, a normalized vector is a unit length vector. And that's it from me for now.